one of the identities on the right hand side of the sheet that I was going to grade for correctness to see that you could do it without me giving you answers, and it was enough of a twist that I figured I better show you how to do this one. So we're going to verify this identity, and I'm going to start with the left hand side. But the twist that they're throwing at us is we're going to recall some stuff you did from Algebra 2 and the early part of this year. If I have to rationalize an expression like this, remember, you got to get rid of the radicals in the denominator. So I'm going to multiply it by a form of 1, so I'm not changing the fraction, just multiplying it. And what I got to remember that this is the difference of two squares. So if I multiply by 1 plus root 3 and 1 minus root 3, there's no middle terms and both get squared. So it's 1 plus or minus root 9. Okay, and the root 9 of course is 3, and then that simplifies. So that's, I won't finish that, but that's the twist we need, is we're going to multiply by the difference of two squares, the conjugate we call that. So, so for this problem, I did that. I multiplied by the conjugate of secant x minus 1, which is secant x plus 1, and I multiplied it through, and of course when I FOIL the bottom, I'm left with the difference of two squares. And then I looked back on the front of the identity sheet, and I saw this identity down in the Pythagorean theorem, Pythagorean identities. And if I move the 1 over, I get this, so that means I can replace the secant squared minus 1 with tan squared, which I did here. And then I noticed that I had a tan x on top and a tan squared. I guess you should have written x there. Okay, and that cancels. I can cancel the tan x and the tan squared, and that leaves me this, and that's what's on the right hand side of that identity, except that should be an x. Alright?